Hey there everybody, Mr. Pardun here, and our next learning target is going to focus on solving multi-step linear equations. So without insulting your intelligence, let's just make sure that we all understand equations are built around this symbol right here, which means an equal sign. The equal sign indicates that two values are exactly the same, and we can place this between two expressions to show that they have the same value. For example, 14 equals 14. Pretty obvious example there. You've seen equal signs used in this way where I can say 7/14 has the exact same value as 1/2. When we introduce variables, you've seen us say that x equals -5, or the value of x is -5. And then finally, in a linear equation, we can say that the expression 2x minus 6 has a value of -11. Now, a good way to visualize equations is to think of things in terms of a balance. This balance is, right now, balanced. And what's that showing? That's showing that these two green squares have the exact same value as this one purple circle. If we show this using variables, we can let g, the variable g, represent the green squares, and we will let P represent the purple circle. So the question that you just had to answer was, well, how many green squares does it take to balance 3 purple circles? Now you can do this logically, and perhaps that's how you did it, but I want to show you how this can be done algebraically as well. From the balance, we can say that 2 g's is equal to 1 p, or 2 green squares is equal to 1 purple circle. But I need 3 purple circles, so I simply multiply this p by 3. Or you can think of it as saying p plus p plus p. But as soon as I do that, I have now unbalanced this equation. They're no longer equal because I multiplied this side by 3. So I have to do the same thing to the other side of the equation, so I get 6 green squares is equal to 3 purple circles. In conclusion, we can say that in order to balance this scale on the bottom, we're going to need 6 green squares. Again, you probably did that logically without even realizing what you were doing, but this is the algebra behind your logical thought. Now, in this example, things get a little bit more complicated. We have 2 balanced scales here, and one of them, we're going to let G represent the green circles. We're going to let P represent, green squares. We're going to let P represent the purple circles, and now we have these red triangles, so that's going to be R. So this first balance on the left-hand side says 3 green squares is equal to 1 purple circle. The balance on the right side says 1 green square is equal to 2 red triangles. But what we don't know right now, we don't have a relationship between the purple circle and the red triangles. So this is where the algebra comes in. So we can very easily use algebra here by substituting 2 red triangles for 1 green square. We know that G is equivalent to 2R from this balance here. So I rewrite my equation on the left-hand side, and I say, instead of 3g equals 1p, I say 3 times 2r equals 1p. That means 6 red triangles is equivalent to 1 purple circle. And again, you could do this logically. It's a multi-step logical approach, but we can also do it with algebra, which is sometimes a little bit more efficient way to come up with answers.